Hi, I'm Elliot, and thank you very much for opening Ruby's webinar on diamond blades. In this webinar, I'm not only going to explain to you how to choose the right diamond blade for the project that you're doing, but I'm also going to explain to you a lot of background information on diamond blades in general so that you know why you're choosing the diamond blades that you're choosing for the project that you're doing. The first thing we're going to do is understand the basic anatomy of a diamond blade. You need to understand that it's composed of two parts. You have the body, which is composed mostly of steel, and on the perimeter, the diamond band. These two parts are unified using various methods depending on the type of blade that you're using.
Okay.
Now we're going to take a moment to focus more specifically on the diamond band. If you look closely at the diamond band, you see that it is composed of different layers of metal, and fixed to those different layers of metal, you have diamond grains. The part of the diamond band that allows us to cut hard materials like stone, porcelain, ceramic is the diamonds. The diamonds are important because they're very, very, very hard, and you need a material with that kind of hardness to cut the things that we work with using these diamond blades. Now, something important to understand about the diamonds themselves is that they have a shape with various points on it, and these points are what make the diamonds sharp. So you have a material that is hard and sharp, which is what allows you to cut materials like stone. The diamond grits can be fixed to the metal band using three methods: sinterization, electrodeposition, and vacuum brazing, and we have an example of each of those here. The most common method is through sinterization, because this gives us a very hard diamond band that is good for cutting materials like natural stone and porcelain. The way sinterization works is we start with a dust or powder made of different metals. We then add diamond grits to this mix of metal powders, and then we put it in a mold. We then apply a very high amount of pressure and then a very high amount of heat to this mix of diamond and metal powders, and this gives us our final resulting metal band. The second method is electrodeposition, or deposition by electrolysis. This creates a single layer of metal with a high concentration of diamond. Electrolysis is a chemical process in which the diamond is fixed to the metal when it is laid in a solution through which a lot of electricity is passed. We find this method used more commonly in drill bits than in blades. The third method is called vacuum brazing, and this is done by soldering the diamond to the metal in an oven. This creates an especially strong unification between the diamond and the metal, and it works especially well when we're using diamond grits that are a bit bigger. This is more common in diamond drill bits than it is in diamond blades. If you stick with us and you watch part 2 of the webinar, you can learn how a diamond blade can lose its cutting capacity, how to restore that cutting capacity, as well as different classifications of diamond blades and much more. When we cut using a diamond blade, the metal band and the diamond can either get spent or lose qualities that make them more capable of cutting through materials. And this is what's referred to as dulling a blade. The more we use a disc, sometimes it loses its cutting capacity or it becomes dull. And this is the result of three different processes. When you're using a diamond blade to cut materials, there are three different ways in which it can lose cutting capacity. The first way is that it loses the outermost layer of diamonds. We talked before about how the diamond band is composed of tiny layers of metal, each of which has diamonds fixed to them. Well, if while you're cutting, the outermost layer loses its diamonds, then you're no longer going to be able to cut. The second way a blade can lose cutting capacity is by losing quality in the outermost layer of diamonds. Remember, we said before that those diamonds have a shape with lots of points. Well, those points are what allow us to cut the material. So if we've cut a lot of material with the same diamonds, those points get used up and the diamonds become dull, and then you can no longer cut anymore, or you lose cutting capacity. The third way a blade can lose cutting capacity is that the outermost layer of diamonds gets destroyed or broken. Now, it makes sense that this happens sometimes because if you're smashing a diamond against a stone because you want to cut the stone over and over again, eventually it makes sense that some of the diamonds will break. Now, although we've divided the three different ways a diamond can lose cutting capacity, Really, it's not good to think that only one of those three things happens while you're cutting. The reality is, all three of them, or any combination of them, can happen a little bit altogether. We now understand that if a diamond blade has lost its cutting capacity, it's because the outermost layer of the diamond band has either lost its diamonds or the diamonds have lost their quality. So what do? We remove the outermost layer of metal so that we expose the next one, which will still have high quality diamonds still attached to it. How do we remove that outermost layer of metal? By cutting through one of these. This is a cleaning block, and it's specially designed so that when you cut through it, it eats away that last layer of metal that's on the diamond blade and nothing more, so that you get the maximum usage out of your diamond blade and you get a totally fresh new layer of metal and diamond. Now that we understand that while we're cutting, we need to use up diamonds, and therefore we also want to use up layers of metal to expose the good diamonds that are underneath, we need to think about how the hardness of the material we're cutting can affect how hard we want the metal that the diamonds are laid in to be. So if you think about it, harder materials like granite are going to use up the diamonds quicker. Diamonds are more likely to break or lose their pointy shape if they're cutting a hard material. So what does this mean? The diamonds get used up quicker, so we want to use the metal faster in order to expose the good diamond underneath sooner. And that way we continue having cutting capacity. That means that when you're using hard materials, you want your diamond band to actually have a softer metal in the diamond band. When you're cutting more abrasive materials, you need to think about the friction that the abrasive materials generate. Abrasive materials are very rough, and it's this roughness that generates more friction than the hard materials. So what you do is you think that the diamond is going to withstand the heat well, but the metal band not so much. So what you do is you make an especially hard metal band that will withstand the friction that these materials generate, so that you can actually take advantage fully of each diamond that is in the blade. Thanks for following me up to this point. In the next section, we're going to talk about the different forms the diamond band can have and how those different forms affect the quality and speed of the cut. Now that we understand that there is an inverse relationship between the quality of a cut and the speed of a cut, we need to think of when we want each. So normally, a good rule of thumb is if the finish of the cut that you're doing is going to be visible at the end of the product or at the end of the project, you should focus mostly on quality of the cut. However, if you're making a cut in a material that is not going to be visible at the end of your project, then you can probably accept a blade that is more focused on speed, because nobody's going to see the finish anyway. And what this creates is an inverse relationship between the speed of the cut and the quality of the cut. There's 5 main forms for the diamond bands. You have the continuous, the J-slot, Viper, turbo, and segmented. The continuous generates the most friction and takes the longest, but it also has the most constant contact with the material you're cutting, so it gives you the best possible quality of cut. The J-slot is similar, but it has these little slits in the diamond band, and in some cases holes in the body of the blade, which allow for better cooling and therefore make the cut quicker. You then have the Viper blades, which are designed to kind of balance as best as is possible velocity and speed. They're kind of the sweet spot in the middle. And you then have the turbo blades, whose main focus is on speed, and that's why they have these slots throughout the diamond band. And then you have the segmented bands, whose focus is almost entirely on speed. They don't really worry too much about the quality of cut here, and when you use this kind of diamond band, usually it's because the final product that you're working with isn't going to show the finish of the cut. Diamond blades cut using friction, and that friction generates high temperatures. So we need to cool the diamond blade. There's 2 ways of doing this. You can do it with the air, which is what you're doing in the case of a dry cut, and then you can cool the blade with water, which is what you're doing in the case of a wet cut. It's always advisable to use water even on blades that are designed for dry cutting, because water will always cool better than the air. And the more we cool our blades, the more resistant they are to being used up when we're cutting. The more you cool your blade, the longer it lasts. In order to know if a blade is able to tolerate cutting at 45 degrees, it needs to be carefully tested. This is because normally when a blade is cutting, it makes contact with the material it's cutting at 90 degrees. If you change that to 45 degrees, the blade is now taking on pressure from the side that it normally doesn't need to handle. Not all blades can handle that pressure, and that's why they need to be well tested. Because if that lateral pressure is too much for the blade, it can bend, and that can ruin your cut. It can also ruin the blade and even ruin your machine if it's extreme enough. So at Ruby, what we do is we let you know when a blade is strong enough for 45-degree cuts, and we also let you know when it's not strong enough for 45-degree cuts, as is the case with the TVA. And that is our webinar and all the information you need to know on diamond blades and how to choose one. Thanks for watching, and if you want to contact us or have any questions, you can do so via our website and our social media. See you at the next video.